Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोस गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोस गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोस रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें पैरेलल एलसीआर सर्किट विषय रे पढिबा and here also we will get the resonance as like that of your series LCR circuit. So देखो प्रथमे जो inductance coil L अच्छी जहाँ को हमें यूज करूँ in this circuit actually some of the resistance is also associated with this coil. Okay, now let an alternating EMF E equal to E0 e to the power j omega t. Okay, E0 हेगला यार peak value, omega हेगला angular frequency, t हेगला time. So let this EMF be applied across the coil of inductance L of some suppose negligible resistance R which is in parallel with a capacitor of capacitance C. Okay, and this is what shown here in this figure, right? So this is the EMF, this is the inductance coil, then resistance, and this is the capacitance which is in parallel. Now here total current जदि देखिबा this is I. ओके एबे एठी ए जो करेंटा दुई भाग हे जाउची गोटे हला I1 ए पटे गोटे हला I2 so I equal to I1 plus I2 and note that in this parallel circuit the voltage across the capacitor C is same as the voltage across L and R एटा तमे जानि छ ओके बिकॉज़ एटे parallel अछि branch so voltage समान रहिबो ओके and they will be in phase at every instant of time. Now suppose Z हेगला impedance of the parallel circuit ताले Z1 और Z2 this will be the impedance of the C and LR branches माने ए branch रो पई आमे suppose कहला Z1 होची impedance और ए branch पई LR branch Z2 हेगला impedance okay so एबे हमें लिखि परिबा ए जो impedance को 1 by Z equal to 1 by Z1 plus 1 by Z2 okay and 1 by Z by reciprocal of impedance is nothing but the admittance so we can also write it as y equal to y1 plus y2 because y equal to 1 by Z okay now the current okay I2 हेगला E by Z2 and similarly I1 हेगला E by Z1 okay and I equal to I1 plus I2 right तो ऊपर जो फिगर टा में देखिला here the impedance across the capacitor C is Z1 और याको हमें लिखि परिबा this is nothing but XC okay that is the capacitive reactance which is 1 by j omega C. Similarly Z2 is for the LR branch that is R and L in series okay so Z2 को हमें लिखि परिबा R plus XL okay that is R plus j omega L ओके ताहले एबे 1 by Z1 1 by Z2 हमें पाई गला राइट एबे जो ई 1 by Z2 अछि याकू टिके हमें सिंपलीफाई करबा हमें कोन करबा तळे आ ऊपरे R minus j omega L मल्टीप्लाई कर देबा ओके सो वी गो फॉर सिंपलीफिकेशन ओके सो यार वैल्यूटा एतकी आसिला ताहले टोटल इंपेडेंस 1 by Z हेगला 1 by Z1 plus 1 by Z2 okay यार वैल्यू गुडा हमें पुट करबा एंड विल सॉल्व इट फर्दर ओके सो 1 by Z रो देखो वैल्यूटा एतिकी आछी एंड नोट हियर दैट दिस इज अ टर्म व्हिच इज रियल टर्म एंड दिस इज द इमेजिनरी टर्म बिकॉज एठी देखो j मल्टीप्लाई हिची ओके सो याको हमें लिखि परिबा लाइक दिस ओके दिस इज द फॉर्मेट हियर यू कैन सी सो एटा आसिला रियल टर्म तापरे एटा आछी imaginary term j into something will be imaginary right so this is can be written in form of y equal to g plus jb okay g हेगला real और b हेगला imaginary so g रो वैल्यू हेला this much और याको कहा जाए conductance बोली और b रो हेगला वैल्यूटा this one right and the angle theta याको आम लिखिपर एज tan theta equal to b by g, and at the resonance position theta रो value टा equal to 0 हबो, right? That is b will be 0. Okay, theta जदि 0 हो गला, that means tan theta भी 0 हो गला, that means b by g will be equal to 0. Okay, but g can never be 0, so b रो value ही 0 हबो. Okay, so b रो value जो एठी अछि, that means in numerator टा ही 0 हबो, और numerator भितरे एठी जो स्क्वायर ब्रैकेट रो टर्म अछि एटा ही 0 हबो. Okay, so आकु आमे बे 0 सहित इक्वेट करिबा, राइट? आ सॉल्व करि गले आमे देखो पाउछु r square plus omega square L square equal to L by C, from which we are getting the value of angular frequency at resonance, that is omega equal to omega 0 is given by the square root of 1 by LC minus r square by L square. ताले resonant frequency f0 ही गला केते, f0 equal to omega 0 by 2 pi. Okay, so 1 by 2 pi into square root of this much, and this is also called your natural frequency of the circuit, right? Acha, now if the value of r is very small, ताले r square by L square जो अछि, this will be very small as compared to 1 by LC. Okay, and the resonant frequency now becomes f0 equal to 1 by 2 pi square root of LC. यही बढ़िया जो resonant frequency तमे series LCR circuit रे भी पाइथिलो. Okay, so the impedance at resonance will be then given by equation 1 जोटा थिला 1 by z, केवल रियल टर्म टा ही रहिबो बिकॉज इमेजिनरी टर्म तो 0 हो गला, राइट? ताले r by r square plus omega square L square, और simply r by L by C, because r square plus omega square L square equal to L by C already हमें पाइचु ये जो equation देखो this one. Okay, एठी हमें already पाइचु, so we put this value, right? So यार value टा आसिला finally z value is L by CR. This is the required value of the total impedance. Okay, so this is the impedance at resonance, and it is called dynamic resistance. Okay, and it is obvious that smaller will be the value of resistance R, then larger will be the impedance Z. And if the value of R is negligible, बहुत जदि छोटा value हो गला, then the impedance is infinite at resonance, right? So if R is small, then there will be an useful approximation for the value of the impedance Z. Okay, याको हमें बाहर करबा जदि 1 by Z equal to एतकी value टा पाइथिला. Now this is simply R plus omega 0 square L square by R. Okay, and we can neglect R as compared to omega 0 square L square by R. So Z रो value हो गला this much. Okay, और याको हमें लिखि परिबा omega 0 L by R into omega 0 L. देखो ये जो क्वांटिटी टा, दिस इज नथिंग बट द क्वालिटी फैक्टर और क्यू फैक्टर. सो क्यू इंटू ओमेगा 0 एल एटा आसिला जेड रो वैल्यू टा, राइट? सो देखो ये जिनस एठी लिखा है ओमेगा 0 एल बाय आर इज नथिंग बट द क्यू वैल्यू. ओके, फॉर द सीरीज रेजोनेंट सर्किट. thus at resonance the impedance of the circuit becomes q times the impedance of the branch line. branch line कहले हमें बुझिबा जो इंडक्टर रो अछि impedance टा बा inductive reactance. Okay, that is omega 0 L, right? Now if the value of q is large, then obviously impedance will be maximum because directly proportional अछि. So resonance रे impedance रो value टा maximum हे गला. So देखो याकू एबे हमें फिगर रे जदि बुझिबा फिगर 7.29. Okay, the first figure here. Okay, so this shows that the variation of the parallel resonant circuit. Okay, here the impedance is taken along the y-axis. Okay, and the frequency is taken along the x-axis. So impedance as a function of frequency for different value of q. Okay, low, high, then infinite भी कला हमें. Okay, so different value of q पाई यार variation दिखाई ची. And remember एठी जदि हमें current रो variation देखिबा in terms of frequency in the second figure, ताले the current will be minimum. Okay, एटा देखो पूरा कमी की minimum हे जाउची at resonance. Okay, so the current is minimum which has been shown diagrammatically in this figure at resonant frequency. ओके आउ जमती आम फर्स्ट फिगर रे देखिला फॉर डिफरेंट वैल्यू ऑफ क्यू जमती क्यू रो वैल्यू कम रोची ताले इंपिडेंस भी कमीगला क्यू रो वैल्यू बढ़िला इंपिडेंस भी बढ़िला राइट अच्छा हेंस at the end we can say that the parallel resonant circuit can be used to suppress the current okay ako ame suppress kari pariba at the resonant frequency because minimum hochi at a particular frequency ame current ko suppress kar daba okay so out of many numbers of current gote particular value of frequency pai ame yaku suppress kar dela hence this circuit is also called as rejector circuit right acha तापरे एबे आकु बढ़िबा लेट अस नाउ सी द रिएक्टेंस स्केच ओके देखो जदि आमे वेरिएशन देखिबा ससेप्टेंस के रो ओके ससेप्टेंस माने इट इज द इनवर्स ऑफ द रिएक्टेंस x okay so k equal to 1 by x so your variation with respect to frequency in case of parallel LCR circuit it's shown in the figure right and here it can be seen that the nature of the variation of this susceptance okay ये जो variation टा देखो it is similar to that of your reactance in case of series LCR circuit okay so ये जो dotted line टा देखो this is showing the reciprocal of capacitive reactance that is 1 by xc which is equal to omega c now a dotted line ta okay or dotted curve ta this is showing the inverse of the inductive reactance that is 1 by omega l okay so the reactance curve can be obtained as a reciprocal of this susceptance curve okay which has been depicted in the figure 7.32 okay अब second figure देखो एटी susceptance को हमें y axis रे नउचु with respect to frequency along the x axis so this is the resonant frequency f0 okay so एटा आछि यार वेरिएशन देखो राइट अच्छा एबे आकु बढ़िबा नाउ ए जो पैरेलल LCR सर्किट अच्छी याकू आम रिजेक्टर सर्किट बोली कि मध्य कहिबा ओके कहीं बिकॉज इट हैज मैक्सिमम इम्पिडेंस एट द रिजोनेंस माने रिजोनेंट फ्रीक्वेंसी रे यार इम्पिडेंस टा मैक्सिमम रोची इम्पिडेंस मैक्सिमम मीन्स इट विल ऑफर द मैक्सिमम ऑपोजिशन टू द फ्लो ऑफ करंट right so it does not allow a frequency which is equal to its natural frequency of the circuit thus it means it suppress or you can say it rejects a particular frequency from a several numbers of frequency that is why it is called a rejector or filter circuit मध्ये याको कुहाय so को जगह रे यार applications अछि जदि देखिबा ताले main application of a parallel resonant circuit is to act as a load in case of output circuit ro load हिसाब रे हमें याको यूज करि परिबा in case of RF amplifier that is radio frequency amplifier right now since in this case the impedance is maximum at the resonant frequency that is f0 so the amplifier gain will also be maximum at this frequency f0 and it has the following advantages number 1 hela it offers the maximum impedance only to the AC signals which is to be amplified and number 2 hela there is practically no DC voltage drop across the coil because its resistance is almost negligible right now एबे देखिबा करंट जो अछि इन केस ऑफ पैरेलल रेजोनेंट सर्किट यार वैल्यूटा एबे हमें बाहर करबा टोटल करंट ओके सो सपोज टोटल करंट बा पीक वैल्यू ऑफ करंट जदि हमें कहबा थ्रू द सर्किट सपोज याको हमें आई नहीं गला एट द रेजोनेंट फ्रीक्वेंसी देन याको हमें मेकअप करंट मध्ये कहि परिबा ओके एंड इट इज रिप्रेजेंटेड एज आई इक्वल टू ई बाय द डायनामिक रेजिस्टेंस दैट इज ई बाय L by CR माने this is nothing but the total impedance जोटा हमें बाहर कला यार वैल्यूटा राइट सो सिंपली यार वैल्यू हेगला ECR by L ओके सो ये जो करंट सपोज हमें कैपेसिटेंस आउ इंडक्टेंस ब्रांच एबे कंसीडर करिबा याकू हमें कहबा फोर्स ऑक्सिलेटरी करंट okay so if I0 is the peak current then the current through the capacitance IC will be how much E into omega 0 C ताले E रो वैल्यू आमे ए इक्वेशन रू पाई परिबा ओके E विल बी इक्वल टू IL बाय CR या को पुट करिबा तळे ऊपरे देखो C कटि गला then we are getting I into omega 0 L by R. Now this omega 0 L by R is nothing but the Q value. So finally we are getting IC equal to I into Q. Similarly, the current through the inductance IL will be E by omega 0 L. Again we put the value of E. एबे तळे ऊपरे L कटि गला. Again at the end we are getting I into Q. That means IL आउ IC रो value समान आछी, right? Hence in a parallel resonant circuit, the current through either arm, okay, is several hundred times of that of your total current. Okay, now oscillatory current au makeup current supply ro ame jodi ratio bahar kariba tale it will be how much I into Q by I. Okay, that means एठी हमें सिंपली पाइला यार रेशियो टा इक्वल टू द Q फैक्टर और क्वालिटी फैक्टर. Thus the parallel resonant circuit or parallel rejector circuit exhibits at resonance a current magnification of value Q which is equal to omega 0 L by R. Okay, current magnification is nothing but the Q value. Okay, and it is same as the voltage magnification as in case of your series resonant circuit. Okay, this is a very important point. Current magnification parallel resonant circuit रे जहाँ voltage magnification series resonant circuit रे सिया. Okay, some further application यदि देखिबा देखो parallel resonant circuit produce oscillations and are used as transmitting circuits. Okay, and in such a circuit the current through the inductance is always equal to the current through the capacitance जोटा हमें ऊपर देखिला. But these have a phase difference of 180 degree between them. Remember, they are 180 degree out of phase, right? And such circuits therefore actually are called as the rejector circuit, and they reject or cut off the currents corresponding to the parallel resonant frequencies, that is F0, and they allow the other frequencies to pass through them, right? And these are therefore called as the filter circuits or rejector circuits, and sometimes also these are called anti-resonant circuits. Okay, remember tomorrow eta practical review ichi series LCR circuit or parallel LCR circuit. Okay, acha ebe akku padiba. Now this is what I have taken for your knowledge purpose, the selectivity which is shown in case of a parallel resonant circuit. Okay, so एथिपाई एबे हमें डायरेक्ट फिगर को जीवा. Okay, figure 7.33. okay, this one, right? So here it shows a parallel resonant circuit which is actually connected to a generator of internal resistance or internal impedance Rg. Okay, and let us say that E dash, okay, E dash be the voltage across the parallel resonant circuit, right? And if this generator voltage E is kept constant and we vary the frequency, then what will happen? This E dash will be approximately equal to this E. Okay, केतेबेले एटा हबो when the value of Rg is small at all frequencies as compared with the impedance of this parallel resonant circuit. Okay, then the circuit will not be selective. Remember, circuit ebe selective hei paribo nahi. But however, jodi ebe ame Rg जो generator रो impedance internal impedance अछि तार value को ebe ame large नहीं जबा as compared with the impedance of this parallel resonant circuit or parallel LCR circuit, then what will happen? The current flowing through the circuit will approximately be equal to E by Rg. Okay, and this E dash will be proportional to the impedance of the parallel circuit. Okay, so since the impedance of parallel circuit is maximum at resonance, eta ame dekhila, so E dash will also be maximum at resonance. Okay, and this is what shown in the second figure, E dash ro variation with respect to frequency. So at the resonant frequency, that is f0, we are getting the maximum value of E dash. Okay, thus at the end we can say the parallel circuits are highly selective when energized from a high impedance generator. जदि बाहरु आमे गोटे generator द्वारा याको energized करिबा, then these parallel circuits will be highly selective, right? Now let us get the expression for the impedance of parallel resonant circuit. Okay, so 1 by z equal to 1 by z1 plus 1 by z2 यार रेस्पेक्टिव वैल्यूज आमे पुट करिबा एंड वी सॉल्व इट फर्दर आगरु जेमती आमे करथिला. ओके, सो एबे देखो आमे जदि कंसीडर करिबा जे ओमेगा एल इज वेरी वेरी ग्रेटर देन आर, ताले एबे ए जो न्यूमरेटर रे आर प्लस जे ओमेगा एल को आमे सिंपली लिखि परिबा इक्वल टू जे ओमेगा एल बोली कि. ओके, ताले जे ओमेगा ऊपरे आउ तळे कैंसिल हो गला. सो वी आर गेटिंग L by C in the numerator. ताले parallel LCR circuit पाई impedance इगला this much. Okay, एबे ई numerator रे हमें तळे ऊपरे omega 0 multiply कर देबा. Now we know that from the resonance condition omega 0 L equal to 1 by omega 0 C. ताले एठी 1 by omega 0 C जगह रे हमें omega 0 L put करिबा. That means the numerator will be omega 0 L रो whole square ही जिवो. Okay, and here ये जो ओमेगा 0 होची गोटे कांस्टेंट, L by inductance ही गला गोटे कांस्टेंट. सो द न्यूमरेटर इज ए कांस्टेंट क्वांटिटी एंड द डिनोमिनेटर इज नथिंग बट द इंपीडेंस इन केस ऑफ योर रिजोनेंट सर्किट, जोटा सीरीज रिजोनेंट सर्किट पाई तमे इंपीडेंस टा पाइथिलो, राइट? नाउ सिमिलरली जदि आमे इक्वेशन फॉर द करंट इन केस ऑफ सीरीज LCR सर्किट देखिबा, ताले करंट रो इक्वेशन आमे एति की पाइथिला E by Z और E by R plus J into omega L minus 1 by omega C. And now here E is also, the EMF is also a constant quantity. So note the equation 2 and 3. Okay, जदि आमे याको कंपेयर करिबा, that means both the parallel impedance and the series current, ऊपरे एटा जो अछि this is the parallel impedance. Okay, so parallel impedance और series current actually both are equal to some constant divided by the same impedance. Okay, which is the impedance in case of your series LCR circuit. Okay, therefore they will have the same resonance curve. Okay, resonance curve in case of parallel impedance can therefore be considered to have the same shape as in case of your series current resonance curve. Okay, and the same working rules will then be applied for estimating the sharpness of parallel resonance circuit. Okay, जोटा हमें previous class रे sharpness टा देखिथिला. Okay, so it can be applied in case of parallel resonance circuit also. Okay, so एबे जदि हमें variation देखिबा in case of parallel LCR circuit, variation of the impedance with respect to the angular frequency, that is omega, which is shown here in this figure. Okay, ये जो omega 0 है resonant frequency, तापरे omega 0 plus or minus half delta omega एटा होउछि तमरो half power frequency, right? So the peak value of the curve is corresponding to the maximum impedance at resonance, that is suppose Z0, which is equal to यारो value हमें पाइथिला केते L by CR. Okay, and for high Q values the bandwidth, okay, BW means bandwidth corresponding to the impedance Z0 by root 2, it has to half power frequency रे, it is called the pass bandwidth. Okay, and the degree of selectivity Q of the parallel resonant circuit is defined in a similar way as in case of series resonant circuit, that is Q equal to हमें पाइथिला series resonant circuit रे omega 0 by delta omega. Okay, एठी मध्ये CI ही हबो. Okay, so the sharpness of the curve can be increased by increasing the Q value of the circuit, right? Now since the resistance R of the coil is taken to be negligibly small, ताले equation 1 जोटा हमें first देखिथिला. Okay, equation 1 माने on the top this one. Okay, this equation, so R को हमें negligibly small नहीं जिबा, ताले एठी देख या को आम लिखिपर सिंपली यही जो टर्मटा अच्छी आर को आम सपोज जीरो नहीं गला ताले दिस विल बी जे ओमेगा एल ओके ताले एबे या को आम यही फॉर्मेट रे लिखिपर यही जो टर्मटा को देख दिस वन राइट सो जे ओमेगा एल तापरे जो उपरे थिला 1 बाय जे ओमेगा सी ताको आम तले मल्टीप्लाई कर देचु राइट सो मैग्नीट्यूड ए इम्पिडेंस आसीज ओमेगा एल डिवाइडेड बाय स्क्वायर रूट ऑफ दिस क्वांटिटी ओके सो फॉर आर टेंड्स टू 0 दिस मैग्नीट्यूड ऑफ द इम्पिडेंस will be equal to z0 magnitude divided by root 2 okay so omega equal to omega 0 plus or minus half delta omega in this case okay and the terms omega L and omega square c square r square जोटा equation 4 रे अच्छी okay this will be approximately equal to omega 0 L and omega 0 square c square r square okay माने ओमेगा को आमे ओमेगा 0 रे रिप्लेस कर देला राइट बट द टर्म्स 1 माइनस ओमेगा स्क्वायर LC will be no longer 0 काहे because since when r tends to 0 then omega 0 will be equal to 1 by square root of LC okay hence for this term we put omega equal to omega 0 plus half delta omega ओके सो या को अभी आम पुट करला ओके आउ बाकी सब जो रिप्लेसमेंट कर सारा ओके सो यार फर्दर एबे आम कैलकुलेशन करबा आम कौन करबा डिवाइड करबा न्यूमरेटर आउ डिनोमिनेटर रे ओमेगा 0 सी आर ओके एंड वी कैलकुलेट इट फर्दर ओके नाउ वी रिप्लेस L by CR with Z0 okay again further calculation okay so this is very simple calculation eta achi neglect kariba ame delta omega square because this will be very small quantity okay so we are getting here delta omega by omega 0 ro whole square ame pauchu okay so eta asila equal to kete LHS रे अछि omega 0 square c square r square that means ebe jodi ame both side रे square root ni jiba tale we are getting delta omega by omega 0 equal to plus or minus omega 0 CR okay therefore the selectivity of parallel resonant circuit that is Q which is equal to omega 0 by delta omega ताले यार value टा केते आसिला 1 by omega 0 CR we have taken the positive value right so it is also equal to omega 0 L by CR we have used here the resonance condition which is omega 0 L equal to 1 by omega 0 C okay ताले या को हमें जदि solve करिबा then we are getting 1 by R into square root of L by C okay अच्छा thus we can say that the selectivity of the circuit that is the parallel resonant circuit here it can be increased by increasing the value of L by C or by decreasing the value of the resistance R okay now let us compare between the series and parallel resonant circuits this is very important या विषय रे short questions exam रे आसी पारे so first point रे series circuit को हमें acceptor circuit बोली की मध्य कहि परिबा because it offers an easy path for the currents at resonant frequency that means the current will have a maximum value at resonance that means for all other frequency there will be a more difficult situation for the current to pass through right now parallel circuit को हमें rejector circuit बोली मध्य कहि परिबा because it offers a difficult path for the current at resonant frequency okay that means the current will have a minimum value at resonance and there will be an easier chance for all other frequency okay बाकी जते सब frequency पाई current easily pass करि परिबो तापरे second point रे the impedance Z at resonance is minimum and purely resistive that is Z equal to R किंतु parallel रे impedance will be maximum and the admittance that is the reciprocal of impedance 1 by Z is actually having a minimum value okay and it is equal to L by CR okay third point current at resonance is inversely proportional to the resistance of the circuit that is I equal to E by R okay resonance रे and it is independent of C and L that is capacity and inductance. Now parallel case re current at resonance is directly proportional to the resistance. It is equal to हमें देखिला जमती ECR by L. Okay, and an increase in the ratio of C by L will increase the supply current. Okay, then come to the fourth point. Resonant frequency f0 जो अच्छी, it is independent upon the resistance R. यार value है 1 by 2 pi into square root of LC. Now parallel case re resonant frequency depends upon the resistance. Okay, f0 equal to 1 by 2 pi, then square root of 1 by LC minus R square by L square. But for small resistances in the circuit, the divergence from the series resonant value, that is 1 by 2 pi into square root of LC, is not very much. Okay, then come to the fifth point. At resonance, it exhibits a voltage magnification which is nothing but the quality factor Q equal to omega 0 L by R. Into parallel case re at resonance, it exhibits a current magnification which is again equal to the quality factor Q equal to omega 0 L by R. Okay, now finally the last point, sixth point, for high selectivity, it should be energized by a generator of low internal impedance. आम जमती देखिला तापरे parallel case re for high selectivity, it should be energized by a generator having high internal impedance. Okay, so this is all about the parallel LCR circuit. Thank you.